Hello students, myself is Mrs. Nita Shashikant Deshmukh. Already we started the rotational dynamics. In that rotational dynamics, we started the numericals. Theoretical part our completed. In last lecture, we completed one example. That was the big example. In this lecture, I am trying to complete the two examples. Again, I want to tell you the use of log table is very compulsory. More time if you are using the log table, it is practice for you in the time of exam. Let me move towards our next example, 14 number. See that the part of a racing track is to be designed for a curvature of 72 meter. We are not recommended to vehicles to drive faster than 260 km per hour. With what angle should be road tilted by what height will its outer edge be with respect to the inner edge if the track is 10 meter wide. As per the given, it is related to our circular motion. Here, which things are given that we are going to write first. Here, R is given. R is nothing but given. R is nothing but the radius of curvature. It is 72 meter. Okay. Next, here the condition is given there. The road is not recommended for the vehicles to drive the more than 216 km per hour. Here the speed is given to us. Here V. But if you are paying attention, 216 km per hour. Here we have to convert this into meter per hour. We can multiply by 1000 divided by 3600. So by solving this, we will get 60 meter per second. Here, instead of that big number, you can use here multiply that term 260 here. Otherwise, this is 5 divided by 18. When we have to convert that speed from kilometer per hour to the meter per second. So that kilometer they are converted into meter and divided by time. Time is in second. So here we can use the two terms. This whole term divided by multiple. Instead of that, we can use this 5 divided by 18. Short form is there. By solving this, I got velocity is 60 per meter second. Another, what we have to find? G. G here we have to take 10 meter per second square. These are the given things. Now we have to, which things we have to find, that we write here. To find, here we have to find out the angle of banking, theta we have to find, and next one, here we have to find the height. That means they are given us. See there, by what height will the outer edge be with respect to the inner edge. That means we have to make a bank road. Outer edge we have to rise through an angle. That angle we have to find out. And the at with height here. Suppose these are the horizontal. Here we have to increase that outer edge with respect to inner edge. That height we have to find out. Now see here. But here the condition is given there. Height we have to find out. But when width is 10 meter. That means the width is given us, it is a 10 meter. Now here we have to use the formula for a optimum velocity. Optimum velocity means it is not a maximum, not a minimum, it is a safe optimum velocity. In that there is no wear and tear of the tire. So let me start the calculation. Here we have to use formula of optimum speed. We know that formula. V optimum is equal to in root Rg tan theta. That formula we have to use, and by this formula we have to find out the value of the tan theta. Here, so we can write here V optimum square is equal to Rg tan theta Therefore, tan theta is equal to V optimum square divided by Rg. Here, the value of that V 60 into 60 divided by the value of R 72 into 10 is equal to 360 divided by 70 is equal to 5. Here we are getting tan theta is equal to 5. Therefore, theta is equal to tan inverse of 5. By finding that tan inverse, theta is not equal. Theta is equal to 78 degree and 41 minute. So this is the value of an angle of 90. Here, theta is equal to tan inverse of 5. With the help of log table, we got the value. At which angle the rod should be tilted. The rod of banking we will get at the angle 78 degree and 41 minute. Now from that we can write here theta is equal to tan inverse of 5. Therefore, tan theta is equal to 5. This also we can write. Now here we have to find out the edge. When see we are talking about the edge, how to find? Curve road is there. Here we have to find out edge. So here we are getting the right angle triangle. We know it is a theta. This is W. This is H. We know the formula. Sin theta is equal to H upon W. We have to find out H. H is equal to W into sin theta. That width is given us 10. Now here we have the value of tan theta. So that tan theta and sin theta, they are interrelated. From that given, we can find out the value of that sin theta. See there, suppose we are using this value of tan theta in such a way. Here is theta. We know how we are getting tan theta. Tan theta is equal to opposite side divided by adjacent. Opposite divided by adjacent. So here we have the value. Tan theta is nothing but the 1. So it will be 5, it will be 1. By using the Pythagoras theorem, we can get this value. How we can get it is the square of two sides. Their addition is there. It is nothing but the square of the hypotenuse. Here this value we will get 26 square of 5, 25 plus square of 1. In square root it is in root 26. Now see here, from that this will become H and this will become W. Okay, so we know sin theta. Sin theta is equal to H upon W. What is the value of H? H is equal to 5. What is the value of W? It is root 26. So this is the value of a sin theta. Very simple mathematical calculation is there. The sin theta, tan theta's values we got by solving this. They are a trigonometric function. They are interrelated. So using that, here we have to use this in equation first. See here we have to use the value of a sin theta. Okay. So here therefore H is equal to W into sin theta. So here its value is there. W how much it is? 10 into 5 divided by into 26. By solving this, 50 divided by in root 26. This is the value of H. Therefore, H is equal to 50 divided by 5.099. We are getting H is nothing but 9.806 meter. This is the height. Very simple example, very easy, related to our circular motion. See, again I will revise that example. In that example, here radius of curvature is given us. Here, the road is not recommended to drive the vehicle fast more than the speed 216 km per hour. That given term is present in the kilometer per hour. that term we are converted into meter per second. If it is given in meter per second and we have to convert in kilometer per hour, here that term we have to multiply by 18 by 5. We have to reverse the numerator and denominator. That tricks they are using in MPSC also. Here the value of G in whole. Here we have to consider the value of G is there 10 meter per second. Here we have to find out the optimum speed. That speed is not a maximum, not a minimum. So in this case also there is no wear and tear of a tire. So that we have to use the formula of a optimum speed. Here optimum speed is equal to in root Rg tan theta. All values are with us. We have to find out the theta by square of that speed is equal to Rg tan theta. Therefore tan theta is equal to V square divided by Rg. Putting the value of V 60 into 60 divided by the value of radius of curvature and the value of G. My simple calculation is there, tan theta is equal to 5. So here theta is equal to tan inverse of 5. So theta is equal to 78 degree 41 minute. As per the log table, that minutes they are going to change. So no doubt, but that angle is 78 degree. Theta is equal to 78 degree and 41 minutes. Now here theta is equal to tan inverse of 5. From that we can write tan theta is equal to 5. Tan theta, sin theta, they are the trigonometric functions, they are interrelated to each other. So as per the given, we know how to find the height. In this case the width is given 10 meters. So here sin theta is equal to h divided by w. This formula we have to use, but we are using the given value and then we are finding the new relation. See that here we found tan theta means opposite side divided by adjacent side. This value we found 5 divided by 1. That value we use in another right angle triangle. So it is the opposite side and it is the adjacent side. So here sin theta is equal to h upon w. By simplifying, here we found the value of hypotenuse in right angle triangle. And this value we put in that first equation. So h is equal to w sin theta. Therefore h is equal to value of width 10 into 5 divided by into 26. Simple calculation is there. Most important thing is there, here you have to use the log table. So h is 9.806 meter and here we got that angle is 78 degree 41 minute. So this way we completed the 14 number example. Let me move toward the next example. 15 number example is there. When you want to write the solution, that time pause the video and write down the all written things. Next example is that the road in the question 14 above is constructed as per the requirements. The coefficient of static friction between the tires of vehicle on this road is 0.8. Will there be any lower speed limit? By how much can the upper speed limit exist in this case? So this question is related to the question number 14. We have to take the given data from that. Here R given in that equation, the R is given. R is equal to 72 meter is there. G's value we have to take 10 meter per second square. V may here the value of V is there 216 kilometer per hour. By converting we will get 60 meter per second. Here they are given us the coefficient of a static friction in between the tires of vehicle and road surface. So here it is 0.8. Here we have to find out the two values, lower speed limit and next is there upper speed limit exists in this case. Is it possible for that upper speed limit? That we have to solve by using that two formulas. So here we have to find out lower speed limit. To find these are the given value. Now next to find out lower speed limit and next is the upper speed limit. We have to check is it exists there, upper speed limit. Two formulas we are going to use here, V maximum and V minimum. So here calculation. First we will write the formula for that. V minimum is equal to under root Rg in bracket tan theta minus mu s divided by 1 plus mu s into tan theta, bracket complete. See that we know if we learn the speed for maximum, that time we have to remember the speed for a minimum. Only there is difference in between the sign. We have to change the sign which is present in the place of numerator and which is present in the place of denominator. Second formula we have to see there, V max here in square root Rg in bracket tan theta, instead of minus we are using here plus mu s divided by 1 minus mu s into tan theta. In both the cases the sign of mu s is going to change. In the case of minimum, the sign at the numerator is minus and sign at the denominator is plus, and in the case of maximum, the sign of the numerator is plus and the sign of numerator is minus. So first we will solve for first equation here. First formula we are going to use, and in second formula we have to check is it exist, that we will discuss afterward. So here V minimum is equal to in root Rg in bracket tan theta minus mu s divided by 1 plus mu s into tan theta. We can put all the values. R is equal to 72 into 10 in bracket tan theta is 5 mu s 0.8 divided by 1 plus mu s 0.8 into 5. Here it is 710. In that bracket what will be left? 4.2 divided by 5. By solving this, I am writing a direct value. You have to use here log table. Finally, V minimum, taking this out of the square root, we will get here 24.59 meter per second. Actually this is our value, but in that answer it is given in kilometer per hour. So here we have to convert that. By doing that conversion, 24.59 we are multiplying here 18 divided by 5, we will get 88.53 kilometer per hour. So this is the value for the minimum speed, lower speed limit at that road. Next we have to check upper speed limit is exist there or not. Let me write the first our formula here. V max is equal to in root Rg in bracket tan theta minus mu s divided by 1 plus in denominator it will be plus, in numerator it will be minus tan theta. So again I repeat, V max is equal to under root Rg in bracket tan theta plus mu s divided by 1 minus mu s tan theta. In this case there is one condition is there. The value in that numerator, it is mu s tan theta, it is less than 1. It is very important. If that value is less than 1, that time you can do the subtraction, because that 1 it is always greater than this value. If that mu s tan theta, if it is greater than 1, that time here we will get the negative value, and velocity is never negative. So if we can check this value, if mu s tan theta is greater than 1, we will get negative velocity. Why? If this value is greater, when we subtracting 1 minus any value which is greater than 1, that answer will come in minus. So velocity is never negative. So let me check our value. Mu s tan theta, that mu s here 1 minus mu s tan theta, 1 minus value of mu s 0.8 into 5. So here we will get 1 minus 4 and the answer will be minus 3. So that means this value is not sufficient, it is not existing, the upper speed limit. So here this value is, it comes in negative and velocity is not negative. So in second case here the upper speed limit is not exist. By here theta is greater than 45 degree. In last example we got the value of theta, it is theta is equal to 78 degree and 41 minute. That means the upper speed limit, it is not exist. Why? The road is banked at angle, that angle is 78 degree 41 minute and that angle is greater than the 45 degree. So this way we completed the second example. In that second example the all conditions are given from the previous example. Radius of curvature 72 meter, g is 10 meter per second. Here static friction is given in between the road surface and the tires of vehicle. Here we have to find out the lower speed limit and here we have to check if the upper speed limit is exist. So by using that formula, see there these two formulas are similar. Main difference is that the sign of a static friction mu s is going to change. In the case of minimum, numerator it is minus, denominator it is plus. In the case of maximum, numerator it is plus, it is minus. If you learn any one, you can write this second with the help of first. So by putting all this value, simple mathematical calculation is there. So finally this value we are getting in meter per second, but in answer it is a kilometer per second. In the exam if you are writing this way still it is correct, no problem. But here we know in that textbook answer is given, so we converted, still it is correct, no doubt in that. So next, in this case we have to check if the upper speed limit is exists there. So here in that the term which is present in the denominator, it is very important. Here mu s tan theta, it should be less than 1. If it is not less than 1, so this value we will get negative. If negative, that means for finite speed it is important that mu s tan theta it should be less than 1. If it is negative, we will get the velocity negative. Velocity is never negative. And also we check is it our value is negative or positive. By solving this, mu s is 0.8, tan theta 5 is solved in that example, so we will get the negative value. So this not exist for upper limit. Here that theta is greater than 45. Such way in this today's lecture we completed 2 numerical. Remaining numerical we are going to solve in next lecture. Thank you.